Hello. So let's quickly go through a program which works with string manipulation. The main focus of this program is this header, which is cctype. So cctype is used to convert the string either to uppercase or to lowercase. Okay. So let's start with main. Our first task over here is you enter a sentence. So getLine method we have already seen in the previous video. First parameter is the scene, second parameter is the string where it will be read. It will be read from the keyboard into the string sentence. Now, next thing is we have to count the vowels as well as we have to count the characters. So we are initializing the counts for the vowels A, E, I, O, U. Now, because our loop variable is also I, we are using IV as an I vowel count basically. And frequency is basically it's like there are 256 characters. Okay, we can actually reduce it only to 128 as well because if we only worry about alphanumeric characters, they fit within the range of up to let's say 128 ASCII characters. Okay, so we can say frequency 128. This is like we are creating an array of 128 characters, and whenever we find any character, we will simply increment the value at that particular index. So, for example, if I encounter small a, then the ASCII value of small a is 97. So, I will say frequency of 97 plus plus. So, that means I have found one more occurrence of small a. If I find capital B, whose ASCII value is 66, then I will say frequency of 66 plus plus. That means I found another occurrence of capital B. Okay. Now this is equal to 0. What does that mean? This means that the entire array is initialized with all zeros. Instead of writing 0, comma 0, comma 0, comma 0, we can simply write 1 0 and it makes sure that everything is initialized with 0. All the counts have to be initialized with 0 and not some garbage value. So now, as we traverse the sentence, this is simple. I equal to 0, I less than sentence dot length, I plus plus. Now, this is interesting part. Here, we are saying char ch. Each individual character we can access using the index sentence of I. We are converting it to lowercase. Okay, so just because we want a count of vowels, whether it is uppercase a or lowercase a, the count of a should increment, right? So, toLower method is used from the cctype library, and toLower method will convert that particular vowel into the lowercase. So, ch will contain the lowercase, irrespective of whether it is lowercase or uppercase. If it matches A, the count of A will be incremented. Similarly, if it matches E, count of E will be incremented. So we are using an if-else if ladder over here to increment the count of every vowel. If it is not one of the vowels, in general, so we are not interested vowels. Even if it is a vowel, we are not interested in that. Basically, here we are interested in incrementing counts of only the vowels, and here we are incrementing the count in general of all the variables. Okay. Now here we are excluding space. Okay. So this is not actually necessary. We can also count the frequency of space, but frequency of space does not make sense. We either count the frequency of alphabets, numbers, or any other character like that. Okay. So we don't want to count the occurrence of spaces. So we are excluding the space. Other than space, now ch is the character. Int ch will be the ASCII value of the character. If you typecast a character to an integer, it will be its ASCII value. And frequency at that particular index, which is the ASCII value of character, will be incremented. Got it? Now, after we are done with this, we will have to traverse this entire frequency array. So we'll set max count to 0 and most frequent character to space. And for j equal to 0, j less than let's say 128, j plus plus. Frequency of j is greater than if we found basically this is the same logic that we use to find the largest element in an array. So if frequency of j is greater than max count and j is not equal to space, then we have found our most frequent character. So max count is equal to frequency of j, and most frequent character is typecast that particular, because j is the index, j is also the ASCII value, because we are using ASCII value as an index within that array, right? So when you convert the j to character, you are converting ASCII value to character, That is, you are finding which is the most frequently occurring character. Okay, so two problems solved. Most frequently, also we have counted the frequency of vowels and we have also found the most frequent character. Next is replace vowels cyclically. Now for that we are creating a copy of our string. So string replace is equal to sentence. And for I equal to 0, I less than replace dot length I plus plus. If is vowel replaced I. Now is vowel is not an inbuilt method. This is a method that we have written. So is vowel, it simply checks whether. So C equal to A, bool, it will return true or false. So if C equal to A, equal to is a comparison operator, it will return true or false. So if C equal to A or C equal to E or I or O or U, if it is one of them, then it will return true. So if it returns true, okay, if it is a vowel, if it returns true, okay, if it returns true, then replaced I is equal to next vowel. Now next vowel is also a method that we have written. In next vowel, now we are also taking care of the case. If the original character is in uppercase, then so this we are checking over here using again the is upper method from the cctype library. cctype library. Okay. So if it is up in uppercase, we will make sure to convert it back to uppercase when we are done with the cyclic rotation. And this is the logic for cyclic rotation. Okay. We convert it to lowercase. Basically, we convert everything to lowercase, convert the character to lowercase. If it is A, next will be E. If it is E, next will be I. Okay. So likewise, we assign the next character depending on what the current character is. Okay. So we initialize next with low and then we actually assign low to this. Basically, we because see, why do we do this? Char next equal to low. We do not want to cyclically shift the consonants. The consonant should remain as it is. So if it is not one of the vowels, then cyclic shifting will not take place. It will still say next equal to low. So consonants will remain consonants at their same exact position. Only the vowels will be cyclically shifted by this logic. Okay. Next is next is reverse each word, but keep the same order. So how do you reverse each word? We find the length of the string. Now, in all these methods, we are passing the string by reference. We are passing the string by reference. We have seen such similar thing in swapping two elements. Okay, and so when you swap with call by value, when you call it from main, the values don't get swapped in main. Whereas if you pass by address or call by address, the values do get swapped in main. So similarly here, when we are passing or when we are calling that string, when we are calling that string from main, okay, when we are passing that string, reverse each word, word reversed. So because it is passed by reference, the effect, whatever is happening there in the string, will be reflected in main. Now let's go back to the method. Now while I is less than n, that is the s dot length, while now nested loop, we want to skip all the spaces. So while I is less than n and si equal to space I plus plus. So all the leading spaces are ignored. Int start equal to I. While I is less than n and si is not equal to space I plus plus, go till space or end. Int end equal to I minus 1. Okay, so we have delimited the entire word with start and end. So if start is less than I, reverse word range s comma start comma end. Here the value of I is at the end. Okay, because here we have progressed I towards the end of the string, right? So if start is less than I, that means the word is non-empty word. So we then go to reverse word range. So how do we reverse the word? Again, here we take the string by address. So here we are passing the string, it is passed by address. So whatever changes we do here will be reflected over here, and whatever changes we do here will be in turn reflected in main, right? So while left is less than right, temp will simply swap SL and SR, start and end markers that we have passed over here. Those will simply be swapped. So first character in the word swap with the last, second character swapped with second last, third character swapped with third last, and so on. And to make sure that after the first, the second should get swapped with second last and then third. So we are also advancing L plus plus so that it advances from first, second, third, and so on. And we are doing R minus minus so that it goes last, second last, third last, and so on. Okay, so therefore the word will get reversed. Okay, and then we'll simply format the output in a nice way. We'll just run this. Let's say our sentence is a simple conventional sentence, hello world, and notice that how the case is also taken care of. So vowel frequency, E occurs once, O occurs twice. Most frequent character is L, occurs 3 times. And after vowel replacement, A, E, I, O, U. So E is followed by I. E के बाद I आता है. So Hilu, O is followed by U, and word, O के बाद U. Consonants remain the same. And words reversed, here again the capital letters, uppercase, they remain the same. Okay. I hope this program was clear to you. If you have any questions, any doubts, don't hesitate to post them in the comments below. Thanks for watching.